Hey everyone, and welcome back to the channel. Are you a B.Tech CSE student looking for an exciting and practical mini project to boost your web development skills and impress your faculty? Well, you're in the right place. In today's long-form tutorial, we're diving deep into building a fully functional weather app using HTML, CSS, and JavaScript, integrating with a real-world API. This isn't just another static web page. Our weather app will allow users to simply type in any city name, hit a button, and instantly see the current temperature, humidity, and a brief description of the weather conditions for that location. It's a fantastic project because it covers so many fundamental concepts crucial for any aspiring web developer: front-end design, asynchronous JavaScript, API integration, and handling dynamic data. So, what can you expect from this mini project? First, a clean and intuitive user interface built with modern design principles. Second, an input field for users to easily search for any city globally. Third, dynamic display of current temperature, weather description, humidity, and wind speed. And finally, robust error handling to gracefully inform users if a city isn't found or there's a network issue. Technologies used. Let's quickly talk about the tech stack. We'll be using HTML for structuring our web page, CSS, specifically the Tailwind CSS framework, to make our app look stunning and responsive with minimal effort. JavaScript, the core logic for handling user input, making API calls, and updating the UI dynamically. And the star of the show for data, the Open Weather Map API, a free and powerful service that provides real-time weather data for millions of locations worldwide. All right, let's jump into the code. We'll start with our index, HTML file. Notice the basic meta tags for responsiveness and the title. Crucially, we're importing the Tailwind CSS CDN directly in our head for quick styling. We also have a custom font, Inter, for a modern look. Our main content resides within this div. It's styled with Tailwind classes for a sleek, rounded, shadowed card effect, making it stand out on the page. Here, we have our input field where users type the city, and a button to trigger the search. Tailwind classes make them look good and responsive. These are initially hidden. They'll appear dynamically to provide user feedback, a loading spinner during data fetch, and a message if an error occurs. This is where our fetched weather data will be displayed: city name, temperature, description, humidity, and wind speed. Each piece of information has a dedicated span with a unique ID, which we'll target with JavaScript. Simple placeholder images are used for humidity and wind icons for a clean look. Now, for the brains of our operation, the JavaScript. First, we grab references to all the HTML elements we need to interact with using document. Get element by id. This makes our code clean and readable. This is super important. You'll see a placeholder your_API_key. Before running this, you must replace it with your actual API key from Open Weather Map. I'll show you how to get one in a moment. This is our main asynchronous function. We start by getting the city name from the input field and trimming any extra spaces. We immediately hide any previous error messages or weather info and show our loading indicator. This is good UX. A basic validation. If the input is empty, we show an error and stop. We build our Open Weather Map API URL, including the city name, your API key, and units equals sign metric to get temperatures in Celsius. This is crucial for robust error handling. Try block. We use await fetch API URL to make the network request. Await response, JSON, then parses the JSON data. We check response OK to ensure the HTTP status code was in the 200s, success. If so, we safely access data. Name, data main temp data, weather 0, description, etc., and update our HTML elements. Finally, we make the weather info div visible. Else within try, if response OK is false, we extract the error message from the API response if available, or show a generic error. Catch error. This block catches any network errors, like no internet connection or other unexpected issues during the fetch operation. We log the error to the console and display a user-friendly message. Finally, block. This code always runs, whether the try or catch block was executed. Here, we ensure our loading indicator is always hidden once the operation completes. We attach and click event listener to our search button, calling fetch weather data when clicked. And for better usability, We also add a keypress listener to the city input field. If the user presses enter, it also triggers the fetch weather data function. Before you run this project, you need your own OpenWeatherMap API key. It's completely free for basic usage. Go to openweathermap.org. Sign up for a free account. Once logged in, navigate to the API keys section in your profile. Copy your default API key, or create a new one. Then, paste that key into the API_key variable in your JavaScript code, replacing your _API_key. Once you've replaced the API key, simply save the HTML file and open it in your web browser. Type a city name like London or Hyderabad. Hit Get Weather and watch the magic happen. You'll see the temperature, humidity, and weather description appear dynamically. By completing this mini project, you've gained invaluable experience in building a responsive UI with Tailwind CSS, manipulating the DOM with JavaScript to update content dynamically, mastering asynchronous operations using async-await and the Fetch API, integrating with third-party APIs, and parsing JSON data, implementing basic error handling for a robust user experience. This is a foundational project that showcases your ability to connect front-end with external data sources, a critical skill for any web developer. This is just the beginning. Here are some ideas for extending this mini project. Add weather icons based on the weather zero. Icon property from the API. Implement a 5-day forecast. Allow users to switch between Celsius and Fahrenheit. Add a recent searches history using local storage. Make it a PWA, progressive web app, for offline capabilities. Integrate geolocation to automatically detect the user's current city. I hope this tutorial was helpful for your B.Tech mini project. If you found this video useful, please give it a thumbs up, share it with your CSE friends, and subscribe for more web development tutorials and project ideas. Let me know in the comments what other mini projects you'd like to see. Happy coding!
Please do like, share, and subscribe, and DM me if you need any help with your projects.